Hi everybody. Okay, so what I did now, I've done another orbital tracking the moon orbit with an LCD1602, as a lot of people will probably have more of this LED than this one here that I had yesterday. Yeah, then this one here. See, this one, it's not a common type of screen, but it's updating all the time. And the same is on this one, it's also updating. But I thought that most of people will have this type of screen instead of this one. I was thinking to do one with this screen, but I don't think I'll be bothered with it. I don't think there is with Nokia. There might not be many people that have Nokia. Although the Nokia is nice because you get much more item in it than in the than in this 2 type of LCD, a small one. Okay, so what we've done here, we can take this one off just now. All right, so what we've done here, we've it's the Azimuth 247 at the moment. That means that the moon is southwest, okay, because it's angulation, it goes 0 is on the north and then it goes all around to 247 and 90 degree. I have put on the, I'll put it on the link how you measure it. And here it says altitude, it's a minus 30.3, because that means that the moon is below the horizon. Okay, so below the horizon, and that means that it's not visible. And if it's above the horizon, usually sometime in the morning, still you can still see the moon. Not every morning though, yeah. But in this case, it's 30.3. It's below, as you can see on the other one as well. Okay, it's below the horizon, 30 point something. Okay. So, yeah. So I just added an extra word here below. And obviously, if you see on the on this, when you go down to, yeah, you see if altitude is greater or equal 0, then above, and else will be below. So it's a logical formula that tells you, and just it will bring the text next to it, yeah, below or above. Although you still have the minus here, which can confirm that you minus confirm that it's under, it's below the horizon, and if there is no minus, it's above the horizon. All right, guys, it's not much. Just similar to the previous one. Use your username and password here. I didn't put a secrets file here. It's a repetition of the previous one practically. And this is my altitude and longitude. So you got to put your latitude and longitude. The reason why you have to do that is because on the calculation, the moon will work from your position. Okay. To track the moon, you need your position. All right. So here, remember why I begin. In my case, because I'm using an ESP8266 Wemos D1, I'm using the SDA and the SCL, it's a D2 and D1. But sometimes you need to initialize it with a wire begin, because otherwise It doesn't seem to work, just like that. And also the other problem you might have is LCD begin. You never know what to put into here, because sometimes your library, the liquid crystal library i2c, sometimes they should have the parameter already, but they don't have. Sometimes if you don't know what to put here, you just put 16.2 or 16.02 and it will work. It will recognize. Otherwise, it will stop here asking for what do you call it? The message, practically, yeah. Okay, and your LCD backlight, so that when every time you reset it, you can see here what happened when you reset it. The computer must go black. See? Go black and then open up Moon Tracker. Okay, if it doesn't go black, it means that it's properly, because it's not initialized. So when you restart, it has to go according to the screen, must go on and off. So to clear, it's clear screen and produce the imaging. Okay, so there we are. The backlight is very important, and LCD clear. And then set the cursor 0 to 0, which is 0 to 0 is here. It's the first block. Okay, 0 to 0 and 0 to 1. All right, I think we covered most of it. There's a Moon Tracker that will pop up, and then it will go through the connect to the Wi-Fi. All right, and then the serial printer connection, Wi-Fi, and so on. And this is to debug in case. And then initialize the NTP client, the network. The time client begin and serial print NTP client initialized. Okay, and that will fetch the correct time. That is the time that. The reason why I do this is because I don't want to use the RTC. Well, this RTC, they cumbersome. Sometimes they work properly, sometimes they don't work. They have library that different type of library, and you struggle to set them up. And I think the best is to get the time directly from online. In this case, it's easier to get the correct time. You don't have to have a battery to charge them all the time. You don't even need a GPS, actually, because GPS also need battery. Okay, so that's my opinion. And here is the convert the epoch to date. So it takes the epoch time from the network, which you initialize here, NTP client initialize. So you'll pick up the epoch time and then convert that into the Julian calendar. Sounds like middle age. And your year, months, because the moon moves around the Earth, but also move around the sun, and has different orbit. It's got its own assets, and the Earth has got its own spin opposite and the assets. So yeah. Then again, you have a clear screen, display azimuth and altitude on LCD. And now it's displaying it here. You can change things if you want. This is actually in brackets here, in the double brackets. It's actually, you can change this one. This one is the result, so you can't change this one. This is the mathematical equation. They give you the azimuth. +1, it's a decimal. So if you put +2, it will give you 2 decimal, but then it won't fit on the screen. You just got to be careful there. And here again, you will see the LCD set the cursor to 0, 1. Okay? So 0, 1. So this is for the horizon. Yeah. Display the altitude with indicators for above. Okay, so it will be on the 0 altitude, which is here, 0, 1. That means this is 0, 0, this is 0, 1. Got it? Hope I got it right. Sometimes you get confused with these blocks. Okay, so there we are. You have the azimuth 0, 0. Azimuth is on the top. And the altitude is 0, 1 because you put the cursor on the bottom, but it's on the same beginning. Start from block 0 to line 1. And this one, it's block 0, line 0. Okay. Remember, you don't use, you always start, it's a binary numbers, you always start with 1. Start with 0, sorry. And the altitude, it's in text, and the altitude plus 1 decimal is the number. It's a number, it's a value from the altitude that will be displayed. So this one also, you can change it. Okay, so if altitude it's larger or equal to 0, LCD print above, or else will print below. Okay, so that means that if the moon is above the horizon, or if the moon is below the horizon. Okay, and here's a calculation with moon position in the year, months, takes the whole, it's quite a long processing. Use float because these are decimal float. They are not integers, they are floats because they have a dot, decimal numbers. So, yeah, and this is all the complex formula that I'm not going to explain here now. And this local, yeah, this distance of 50,000 kilometers from the Earth, but not always. It varies between 280 and 360,000. Lots of orbital are not a circle; they are oval, elliptical. So that means that sometimes it's like Mars. There are some time of the year Mars is closer to the Earth, and some other time it's twice the size away. So yeah, because it's elliptical. Elliptical orbital has a furthest away point from the two highest point, and the two closest point are the closest to the center. Okay, so return here and so on, the conversion, the epoch to the date. This is how you do the conversion. Okay, guys, I think, and there it is. Let's reset it. Also, on tracker. Okay, so one thing that I just want to explain about this one, I put it on yesterday, and I've added on an update. So in order an update so that you can see the azimuth, altitude, and I add below horizon or above horizon. In this case, it's below because it's a minus. Okay, so yeah, so if you got downloaded the first page from GitHub, there is another page now that you can update it and put it. Even I made it yellow, but you can make it green as well. You just type in capital letter, take the yellow off, and put green, and it will look nice as well. Obviously, this one has got no color, so it stays like that. It's just this one is different. I can actually quickly show. Right. Okay, I think you can see now. Okay, this is an orbit with LCD. That's a moon tracking update, which I've done it again for, see here, same processes, you know, my coordinate, moon orbit tracking and so on. And here you can change it. This is yellow, okay? So you just start green here. If you have the same screen as this one, it will appear green, okay? And yeah, so that's about it. And if you reset it, it will do exactly the same as the other one. When you reset, it should go dark. There you are. And then reset. And then the moon track. Just take a bit of time to get the coordinate and then bring them in front. Okay, so there we are. All right, guys. Well, thank you very much. You have a fantastic day, and good luck with the election. It seems that you got a new president in the United States, in particular. Okay, have a good day. Bye.